Hello, Steve. This is the response to Steve Patterson on his videos about the nature of infinity. Especially, I want to focus on the principle, on the concept of infinity and infinite sets in the light of the philosophical principle of identity, which every good philosopher should know. So, we need better semantics because infinity literally means incompleteness, quote unquote. But infinity is actually quite opposite of incompleteness. Infinity is the concept of absolute completeness in the way that zero or any other number is absolutely complete. You cannot add anything to it without changing its identity. So, real things like numbers have principle of identity. And Steve, you talk about incomplete sets. You talk with mathematicians about them, and these incomplete sets seem to be infinite in their cardinality. But I think that we need good semantics in cardinality as well. It could be a misconception that infinite sets do not have cardinality. They are not the type of a mathematical object or concept that can potentially have cardinality. They cannot. Think of the joke. I'm sorry to women, but think of the blonde that who ordered a pizza. The waiter said, "Do you want to split the pizza to 8 or 12 pieces?" And the blonde said, "8." Answered the blonde, "I could never eat 12." So you get it. Usually we think the more sum of something there is, the greater cardinality it has. But think of cardinality in incomplete sets, in the infinite set, as the numerator in a fraction division. So those of you new to English and mathematics, fraction division has denominator on the top and numerator on the bottom. The greater numerator, the more you divide the denominator, and the smaller is the final fraction. So the incomplete sets are just finer or coarser ways to divide the infinity, quote unquote infinity, but the overall amount of whatever infinity is remains the same. It's just division. It's just one complete infinity after all. For more evidence or arguments of this idea, if I understand this correctly, the fact that, the fact that the incomplete infinite sets do not have identity, therefore they do not have cardinality, is reflected in the Banach-Tarski paradox. Basically it's mapping infinite points onto a sphere with some spacing in between, and otherwise we would end as soon as we started. So you can perform some transformations and you get two sets of points, basically two spheres, if you define the sphere as an infinite set of points, which I'm not sure is the correct thing to do. Basically garbage in, garbage out, I think. So another thing I need to say is this: logic and mathematics are static. What does it mean? They are a priori knowledge. No matter how large an equation is, it has the same meaning or the same value as the same equation, just simplified after many long steps and clever transformations. Basically, you have a huge equation, but you can perform some steps to simplify it, and the simplified equation has the same validity, same meaning, same values as the unsimplified. And this is what nobody told me at school, that basically when computing we are simplifying equations. Basically, once you get over the basic algebra, you never find out what the ABC XYZ means. That's all we do is simplification, as far as I understand it. Nobody told it to me. Thank you, government school. So moving on. When you simplify, when you compute the equation, there is literally no time, zero steps between the initial and the final form of the equation, logically speaking, provided it's valid, of course. That is what does it takes for the squiggles, for the words, for the mathematics to have this to have this philosophical property of identity. Well, no, what was it about the infinite sets? Think of the Hilbert paradox of the infinite hotel room. You can read about it on Wikipedia. The point is, even though all rooms in an infinite hotel are occupied, we can always kick out the tenants and move them into a room with a higher number, and so the full hotel can always accommodate an infinite number of new tenants, basically. There are many tricks about it, but the problem with that is we cannot do that, actually. Not with the principle of identity. There is no place in mathematics for the gradual transformations that take multiple steps in the virtual world of the hotel. There is no hallway in the mathematical hotel to kick the tenants out. The hotel was defined as full, so it cannot be not even hypothetically full except one room. We cannot kick one tenant out. It wouldn't be the same hotel as we defined it. So it has to be static. That's what it takes to have identity. If we change it on the go, it doesn't have identity. It is literally a nonsense. It's arbitrary fairy tale, not mathematics. Even though we keep with all other rules, that's what it takes to do real mathematics. Some radical skeptics did this mistake with logic, but I would have to look into my notes for that. So, final point. Is there some kind of use for the infinite sets? Steve Patterson, you tell me. I keep hearing from you and from these people that you interview that these academics, how useful the infinite sets are. The professors say maybe it's something like a shorthand. Like I have done some programming in some game making languages. It is permitted to use variables without defining them first. This is a big no-no in C++ or any other self-respecting game or computer language, because you first have to define all the variables that you will later use, and you have to define them in proper size. But there are some languages that allow you to use variables on the go out of nowhere, and they typically have like zero value. It's like treated as a zero, basically. And I like it. It's convenient, and I think, well, the result is basically the same. It's just eat a shitload of memory. It's not very well optimized, but it's very convenient for quick game making ideas. And I spent a lot of years on it. So I think that these so-called infinite sets could be some kind of mathematical shorthand like that. Yes, they are efficient because nothing ever runs on them. It's like efficient in terms of saving the brain capacity or time of the mathematicians. That's basically it. Just like the undefined variable that I use is saving my time when trying my silly ideas on the Game Maker Studio. So it's basically a metaphor. In mathematical speech is a metaphor, and it's useful, and it cannot be taken into too literally or it breaks down. And it's useful to get some ideas across, but yet that's what I think it is. It doesn't have the the principle of identity. I think, yes, this what I just said, that's a metaphor too, but you see what basically you get a rough patch on a rough potato sack, as some people say. So this is my point about the principle of identity and infinite sets. And I would like your response, or just a note that you have listened to this already. So thank you, and have a nice day. Bye bye.